So the first thing, I'm not receiving homework from some people. I will put up a list in the evening. You should send your homework to me and to Amanshri sir. Please make sure that you send it by today, right? Lecture 6. Okay, so I think we will discuss a couple of questions and then we will so the first question that I wanted to talk about was, I think somewhere somebody was asking me that we have to prove the cosine rule and the sine rule. So in maths, basically, if you have a triangle, we will call this angle A. The opposite side will have a length of small a. If this is angle B, then the opposite side has a length of small b. And obviously, if this is angle C, then this opposite side has a length of small c. So the cosine rule says that cosine of A is equal to, please remember, this is not a right angle triangle, okay? This is any triangle. मैंने म्यूट तो नहीं किया हुआ है, मेरी आवाज आ रही है? कैन यू हियर मी? बाकी लोग तो बोल रहे हैं यस. नहीं सुनाई दे रहा है तो व्हाट यू डू इज यू क्विट एंड यू रीजॉइन. फिर से ज्वाइन करो. So cosine A is equal to B square plus C square minus A square divided by 2B, to be seen here because there's a pattern to be seen here because just a minute, please. हाँ गई दृष्टि दिखाई नहीं दे रहा है नाम. अरे अब सुनाई दे रहा है? अगर नहीं सुनाई दिया किसी को, प्लीज यू नो जस्ट disconnect and rejoin again. So cosine of B is equal to A square plus C square minus B square divided by AC, and cosine of C is equal to a square plus b square minus c square upon 2ab. Right? So you take any one of them, they are called the cosine rule. They are called the cosine rule. तो हाँ 2ac होना चाहिए, हाँ 2ac. Right? I hope you can spot the pattern. It is basically that if you're taking this angle, then you're supposed to square the two adjacent sides, add them up, subtract the opposite side square, divided by twice the product of the two adjacent sides, right? Right, so I want to prove this. In fact, I don't have to prove this because I've already done it for you. Okay, can you guess where this was done? Can you guess where we derived the cosine rule? कहाँ derive किया था हमने cosine rule? याद है किसी को? Can you guess? नहीं, not direction cosines. No, it was much more simpler than that. ये डायग्राम किसी को याद है? नहीं, ये डायग्राम किसी को याद है? मैं सीधी लाइन नहीं बना पा रहा हूँ. Do you remember this? Triangle law of addition. Excellent, very good, yes. So if I have this as the angle theta, right? Please notice what I'm going to do. Let me not take this as angle theta. Let me take this as angle A. Okay. So this is side A. Let this side be B. Let this side be C. याद आया अभी तक किसी को? नहीं. देखो. I am looking for right angle triangles. Can I see? I am looking for right angle triangles. Can I see the right angle triangles? कहाँ है right angle triangle? Yes. I am supposed to drop a perpendicular. So I draw this line and I drop a perpendicular. Now what? Now what? अब क्या करें? So if तो भाई अब क्या करें? हाँ, good, yeah. So oops. So let this angle be theta, and if this angle is equal to theta, then this side of the right angle triangle is A cosine theta. This side of the right angle triangle is A sine theta. Right? And we look at the perpendicular A sine theta over there. And then we look at the larger right angle triangle. Yeah, we look at the larger right angle triangle. In the larger right angle triangle, if I apply Pythagoras, I should get I should get b square is equal to a sine theta whole square plus c plus a cosine theta whole square. Right? This is Pythagoras in the larger right angle triangle. So this will be equal to b square is equal to a square sine square theta plus c square plus a square cos square theta plus 2ac cos theta. Right? ठीक है ना, मैंने कुछ किया नहीं है, मैंने केवल परपेंडिकुलर ड्रॉप करके देखा कि मेरे पास दो राइट एंगल ट्राइंगल आ रहे हैं। एक राइट एंगल ट्राइंगल जो छोटा वाला है उसका हाइपोटेन्यूज दिया हुआ है, तो मैंने उसमें एक एंगल अज्यूम कर लिया और मैंने उस राइट एंगल ट्राइंगल के दो साइड्स लिख लिए और उसके बाद से मैंने जो बड़ा वाला राइट एंगल ट्राइंगल है उसके ऊपर मैंने पाइथागोरस थ्योरम लगा दिया। अब ये जो ए स्क्वायर साइन स्क्वायर थीटा है और ए स्क्वायर कॉस स्क्वायर थीटा है, इसमें ए स्क्वायर कॉमन हो जाएगा, साइन स्क्वायर थीटा प्लस कॉस स्क्वायर थीटा 1 हो जाएगा, राइट? So what will I end up with? Well, I will end up with, I'm going on to the next slide, I'll come back to this. So what do we end up with? We end up with b square is equal to a square, right? Cos square theta plus sin square theta तो 1 हो गया, right? A square plus c square plus 2ac cos theta. So b square is equal to a square plus c square plus 2ac into cosine of theta. राइट? ये तो हमारा रिजल्टेंट वाला रूल है ना, ये तो हमने पढ़ा हुआ है, ये तो हमने डिराइव किया हुआ है। बट इफ यू लुक वेरी वेरी केयरफुली, राइट, इफ यू लुक वेरी वेरी केयरफुली, देन दिस एंगल मस्ट बी बी, राइट? अगर मैं एक नॉर्मल स्केलिन ट्रायंगल की बात कर रहा हूं, तो अगर एक साइड का लेंथ b है तो उसके ऑपोजिट एंगल की वैल्यू कैपिटल B होनी चाहिए। अभी हमने देखा था, ये तो ये नॉर्मल ट्रायंगल की खासियत है। तो थीटा और b में क्या रिलेशन है? व्हाट इज द रिलेशनशिप बिटवीन थीटा एंड b? The relationship between theta and b here is obvious. Yeah, so theta is equal to 180 minus b. So I can write here b square is equal to a square plus c square plus 2ac cosine of pi minus b. Right? What is cosine of pi minus b from your trigonometry lessons in mathematics? What is cosine of pi minus b? It will lie in the second quadrant. Yeah, so it will be minus 2ac cosine b. So I'll take the 2ac cosine b on the left hand side and I'll get the b square on the right hand side. So I get 2ac cosine b is equal to a square minus plus c square minus b square. And therefore I get cosine b is equal to a square plus c square minus b square whole upon 2ac. Right? Which was the original one of the yeah. So how do you derive cosine rule? Well, cosine rule is nothing but our resultant vector wala formula. a square plus b square plus 2ab cos theta, that is cosine rule. So the cosine rule is simply telling me that the third side of a triangle square is equal to the other two sides का square का sum plus twice of the product of the other two sides multiplied by the cosine of the angle between the two sides. This is the cosine rule. Okay, so now what I want you to do, I'll give you 5 minutes. I'll give you 5 minutes and I want you to prove the sine rule. Yeah, and what is the sine rule? What is the sine rule? Sine rule is that again, if you have a, this is not a right angle triangle, B, C, C, then sine A upon A is equal to sine B upon B is equal to sine C upon C. Okay. Don't worry about any other method. Try using vectors here. जैसे मैंने अभी वेक्टर सम यूज किया, ऐसे यहाँ पे try using vectors. Okay, I'll give you 5 minutes. कैसे प्रूव किया? क्रॉस प्रोडक्ट यूज करके। एक्चुअली यू कैन, इसमें भी परपेंडिकुलर ड्रॉ करना है।
हाँ सर, अंदर ट्राइंगल के, लेकिन परपेंडिकुलर आप सी से ए बी मतलब एंगल सी से लाइन सी तक एक परपेंडिकुलर ड्रॉ कीजिए, फिर ऐसे एक रिलेशन निकलेगा, दूसरा फिर परपेंडिकुलर ड्रॉ करेंगे तो दूसरा रिलेशन निकलेगा और इक्वेट कर सकते हो उसको।
एक मिनट, हम क्या बोल रहे हैं? ये ए है, ये ए है, बी है, ये बी है। हाँ बता फिर से।
सर एंगल बी से लाइन बी तक एक परपेंडिकुलर ड्रॉ कीजिए।
किया।
तो सर साइन साइन ए इज इक्वल टू जो भी परपेंडिकुलर है अपॉन सी। तो सी साइन ए इज इक्वल टू परपेंडिकुलर।
अब
तो सी साइन ए इज इक्वल टू परपेंडिकुलर, ये फर्स्ट इक्वेशन होगा। दूसरा इक्वेशन हुआ कि
अच्छा,
हाँ
अब मैं यहाँ से परपेंडिकुलर ड्रॉप करूँ,
हाँ
तो यहाँ से मैं परपेंडिकुलर ड्रॉप करूंगा। अगर मैं सी से परपेंडिकुलर ड्रॉप करूंगा, मुझे ऐसे जाना पड़ेगा।
हम्म,
ये जो येलो वाला राइट एंगल ट्राइंगल है, उसमें मुझे क्या मिलेगा? साइन ए इज इक्वल टू परपेंडिकुलर अपॉन बी, एंड आई विल गेट और क्या आएगा? साइन ऑफ पाई माइनस बी इज इक्वल टू परपेंडिकुलर अपॉन ए। उसी तरीके से तीसरा भी रिलेशन आ जाएगा। तो साइन पाई माइनस बी क्या होता है? साइन बी होता है। कहानी खत्म हो गई। कह दिया सबको? आया समझ में क्रिश? क्रिश समझ में आया? क्रिश, यस और नो? क्यों इतना लेट आ रहा है फिर? हाँ, any right angle triangle, I don't care. This is a generic. Oh, okay. अरे राधिका, तो हो गया ना? दिस इज, अच्छा चलो मैं फिर से कर रहा हूँ। दिस इज ए जेनेरिक राइट एंगल ट्राइंगल. दिस एंगल इज बी, this side is B, this angle is C, this side is C. So I drop a perpendicular from the head of B. Look at the left hand side right angle triangle and tell me the value of sine A. Look at the right hand side right angle triangle and tell me the value of sine C. Sine A is the blue perpendicular length upon hypotenuse, which is C. Sine C is the blue perpendicular length upon the hypotenuse, which is A. यहां तक आया सबको समझ में? यहां तक सबको समझ में आया? हाँ या नहीं? Now what I do is I carry out the same procedure, but this time I'm going to drop a perpendicular from some other vertex. I decide to drop a perpendicular from this vertex, but I cannot drop a perpendicular from inside the right angle triangle, so I have to do it from the outside because of the triangle that I have drawn. I could have drawn the triangle in some other way, तब ये अंदर से भी चला जाता, ठीक है, कोई फर्क नहीं पड़ता. Now again I have two right angle triangles, and I can write sine A is equal to the green perpendicular upon hypotenuse, which is B, and sine of pi minus B. Where is pi minus B? Where is pi minus B? This angle is pi minus B. Sine of pi minus B is equal to green perpendicular upon the side A, upon the hypotenuse of that triangle, which is A. ये आया समझ में? Second relation. Second relation आया समझ में? Yes or no? सबको आया? अभी साइन रूल हो गया प्रूव? दिखाई दे रहा है कैसे प्रूव हुआ? ये जो नीचे वाले दो इक्वेशंस हैं, ये जो नीचे वाले दो इक्वेशंस हैं, यहां से मैं लिखूंगा C इंटू साइन A is equal to A into sine C. This tells me that sine A upon A is equal to sine C upon C. Right? और ऊपर वाले जो दो रिलेशन है वहां से मेरे पास क्या आएगा? यहां से मेरे पास आएगा B sin A is equal to A sin B, which is sin A upon A is equal to sin B upon B. मैंने कुछ तो लोचा लिख दिया. Sin A upon A is equal to sin B. हो गया प्रूफ? हो गया प्रूफ? Yes. But here's the thing. Okay, here is the thing. We did not use vectors. Okay, this is not using vectors. This is just trigonometry. Can you prove this using vectors? Can you use this? Can you prove this using vectors? हाँ, बताओ भाई आर्यन कैसे करना है? You tell me. So we have the triangle AA BB CC. हाँ, नहीं तो क्रॉस क्या मतलब? व्हाट डू यू मीन बाय क्रॉस प्रोडक्ट भाई? व्हाट डू यू मीन बाय क्रॉस प्रोडक्ट? व्हाट डू आई राइट? क्या लिखूं मैं अब? व्हाट डू आई राइट? व्हाट डू यू वांट मी टू राइट? A plus B plus C is equal to 0. Okay. So what Aryan is saying is that if I consider a vector, if I consider a vector B and a vector A and a vector C, then the vector A, remember that अभी जो मैं कैपिटल लिख रहा हूं ये एंगल्स नहीं है, ये वेक्टर है. A plus B plus C is equal to, जो भी ट्राइंगल है मेरे पास, राइट, इट इज नॉट ए राइट एंगल ट्राइंगल, इट इज ए जेनेरिक स्केलियन ट्राइंगल. तो जो भी ट्राइंगल है मेरे पास, राइट, उसमें मैंने क्या किया कि तीनों साइड में मैंने वेक्टर बना दिया, विच आई कैन डू, राइट. मैंने एरो बना दिया साइड, एंड आई गेट A plus B plus C इज इक्वल टू 0. हाँ भाई, अब क्या करूं मैं? अब मैं क्या करूं बताओ आर्यन? we can take the cross product of all vectors with A. Excellent, very nice. So I take the cross product on both sides. I get A cross A plus B plus C. Right hand side में तो कोई फर्क ही नहीं पड़ेगा. If I'm multiplying a vector by 0, I'll get a 0. I don't need to write this. And if you remember, we discussed the properties of cross products, right? So one of the properties of cross products was that you can open the brackets just like you do in algebra. Yeah, so I'll open the brackets. I will get A cross A plus A cross B plus A cross C is equal to 0. हाँ, अब क्या करें भाई आर्यन? ये तो आ गया, अब क्या करें? A cross A will be 0. Absolutely right. A vector having cross product with itself is always 0, because remember that a vector is parallel to itself. Parallel and anti-parallel vectors always have a cross product of 0. अब so now I can write A cross B is equal to C cross A. Right? How can I write this? A cross B is equal to C cross A. ये कैसे लिख सकते हैं अपन? बोलना जोएब.
हाँ सर, मैं वही बोल रहा था कि हम लोग A क्रॉस B इक्वल टू C क्रॉस A लिख सकते हैं.
यही बोला था क्या?
क्योंकि वो उधर जाएगा तो नेगेटिव हो जाएगा, और अगर नेगेटिव है तो हम स्विच करके लिख सकते हैं ना, क्योंकि बस डायरेक्शन फ्लिप होगा.
एक्सेलेंट, एब्सोल्युटली राइट, बहुत बढ़िया. तो अगर हम A क्रॉस C को दूसरे साइड ले जाएंगे तो माइनस A क्रॉस C हो जाएगा, एंड माइनस A क्रॉस C इज C क्रॉस A. जोएब अपना वो कर ले, लोअर हैंड कर ले. अब A क्रॉस B इज इक्वल टू मैग्नीट्यूड ऑफ A मैग्नीट्यूड ऑफ B मल्टीप्लाइड बाय साइन ऑफ द एंगल बिटवीन A एंड B, and this is equal to magnitude of C magnitude of A into sine of the angle between A and C. तो magnitude of A तो कैंसिल हो जाएगा. मेरे पास क्या बचेगा? magnitude of B, which is B, into sine of the angle between A and B. वेक्टर ए तो ये मुझे दिखाई दे रहा है, वेक्टर बी मुझे दिखाई दे रहा है, एंगल बिटवीन ए एंड बी क्या है? रिमेंबर, एंगल बिटवीन ए एंड बी के लिए आपको क्या करना पड़ेगा? एंगल बिटवीन ए एंड बी के लिए आपको क्या करना पड़ेगा? एंगल बिटवीन ए एंड बी के लिए टेल्स कोइंसाइडिंग होने चाहिए, राइट? So this is vector B. What is the angle between A and B? The angle between A and B must be this angle. So this will be sine of pi minus C is equal to the angle between A and C, right? So let me just redraw the vector C properly in a different color. What is the angle between A and C? Tails together करना पड़ेगा ना? Angle between A and C तो ये है, which is pi minus B. So this should be equal to C into sine of pi minus B. Right? B, capital B. Lekin sine pi minus B, pi minus C really does not matter because sine pi minus theta is equal to sine theta. Right? Excuse me. So यहाँ से मेरे पास आ गया sin C upon C is equal to sin B upon B. फिर A वाला कैसे लेके आएंगे भाई? क्या करना होगा अभी इसमें? क्या बचा हुआ है? What will I do? I'll go back to this expression, and this time instead of taking cross product with A, I will take cross product with B. Okay, I'll take cross product with B, and I'll get another expression which should prove the sine rule. If it does not prove the sine rule, मतलब अगर आपको third expression तब भी नहीं आ रहा है, you go back to this expression and this time take the cross product with C. तो A plus B plus C is equal to 0 में हमने एक बार A के साथ क्रॉस प्रोडक्ट लिया दोनों साइड, फिर उसके बाद से B के साथ क्रॉस प्रोडक्ट लिया दोनों साइड, उसके बाद से C के साथ क्रॉस प्रोडक्ट लिया दोनों साइड, and that gives us the sine rule. आया समझ में सबको? Is understood? Anybody who's not understanding, please type no. Oh, why did we take cross product? Oh, that is a very nice question. I took cross products because I know that I want the appearance of sine. Cosine rule mein, I knew that I wanted the appearance of cosine. Therefore, I went for addition of vectors. Whereas here I know वहां पे डॉट प्रोडक्ट भी कर सकते थे, यहाँ पे अपन क्रॉस प्रोडक्ट इसलिए कर रहे हैं क्योंकि मेरे को मालूम है कि आंसर में साइन आना चाहिए, राइट? इसलिए हम क्रॉस प्रोडक्ट कर रहे हैं. Next thing what we want to do is we want to briefly talk about vectors in physics. Okay, so there are a lot of vectors in physics. Some of you may have heard about, some of you have not heard about. For example, displacement is a vector in physics. Velocity is a vector in physics. Acceleration is a vector in physics. Force is a vector. Momentum is a vector, right? These are things you have heard about. Okay. Things you have not heard about. The electric field is a vector. The magnetic field is a vector. The torque is a vector. The angular momentum is a vector. So these are the vectors you have not heard about. Irrespective of the fact that you have heard or not heard about a vector in physics, they are all going to follow the same rules of addition, of subtraction, of multiplication. So in this part of the chapter, in this last part of the chapter, what I want to do is I want to show you how vectors will be operating in physics. And since you know or you have a basic knowledge of some of the vectors, I will only deal with those vectors in this part. Needless to say that whatever we are discussing here, we will discuss again when we discuss motion, kinematics. Apart from that, needless to say that whatever we are discussing here is also applicable for all the other vectors that I'm not going to show you here because you have not heard about them as yet. But as and when they are introduced to you, they are going to follow the same laws, the same procedures as we will discuss for some of the vectors here. So first, I want to talk about a vector which you have not heard about before. It is called the position vector. Okay, and I want to talk about this because it's actually very simple to figure out. Yeah, it is also called the radius vector. Yeah. So the position vector has a special symbol R. Right? We'll be discussing all these things again. And it is simply a vector which is drawn from the origin to the position of the particle, as the name suggests. Right? So we are dealing with a particle. I have not defined what a particle is as yet. I will do that when we start with the kinematics. So for the moment, we'll make do with the definition of particle that first pops in your mind. A particle is literally a point object, right? And we have some coordinate axis somewhere in space. This is the x-axis, this is the y-axis. There should be a z-axis as well, but since I cannot draw it readily, I'll forget about it. And the particle is somewhere here. So I draw a vector from the origin to the location of the particle. And this is the position vector of the particle. Right? As you should have guessed, that as time goes on, the position vector of the particle will change. Right? So maybe after some time, the particle is here. And this is the new position vector of the particle. So what I can say is that this is the initial position vector of the particle, Ri, and this is the final position vector of the particle, Rf. And now I'm in a position to define the second vector that you will be dealing with in physics. Now, unfortunately, आपने इसके बारे में पहले से पढ़ा हुआ है. Unfortunate इसलिए है क्योंकि जो चीजें पहले से पढ़ी हुई हैं उनका कुछ तो डेफिनेशन दिमाग में रहता है, कुछ पिक्चर दिमाग में रहती है. That picture is not necessarily going to carry on. I'm not saying that that picture is not true. Whatever has been taught to you, it is absolutely true. But now we want to look at it from a higher perspective, right? Now we want to make it the scientific part of it. We want to make it more credible. We want to make it more solid. So the next vector we define as the displacement vector. Right? Now you may have learned the definition of displacement vector as the shortest path or this and that. अब हम वो सब नहीं काम कर उससे नहीं काम करेंगे. अब हमारे लिए जो displacement vector का definition होएगा वो होएगा a vector drawn from the initial position to the final position of the particle. Right? तो आप एक arrow बना रहे हो जिसका टेल इनिशियल पोजीशन पे लाई करता है पार्टिकल के और हेड फाइनल पोजीशन पे लाई करता है पार्टिकल के. जो भी एरो बनेगी ये उस पार्टिकल का उस टाइम इंटरवल के ड्यूरेशन में उस इनिशियल और फाइनल पोजीशन के रिस्पेक्ट में ये उसका डिस्प्लेसमेंट वेक्टर होएगा. राइट? ये होएगा डिस्प्लेसमेंट वेक्टर डी. किसी को कोई तकलीफ? राइट? कुछ परपेंडिकुलर नहीं है यहाँ पे. देयर इज नथिंग परपेंडिकुलर. डायग्राम में अगर कुछ दिखाई दे रहा है तो वो गलत दिखाई दे रहा है, वो मेरी गलती है, मुझसे डायग्राम ऐसा बन गया है. देयर आर नो राइट एंगल ट्रायंगल्स हियर. देयर मे बी, देयर कैन बी, बट देयर आर नन in the diagram that I have drawn. Okay. Now please look carefully at the three arrows, the green arrow, the red arrow and the blue arrow. Just by looking at the three arrows, can you tell me from your newly acquired knowledge of vector mathematics, what is the relationship between the three arrows? What is the relationship between the blue arrow and the red arrow and the green arrow? The sum is 0 is not the correct answer. Okay, the sum is 0 is not the correct answer because this does not form a polygon. क्योंकि जो blue arrow है उसके head से red arrow बना, लेकिन जो green arrow है वो blue के tail से red के head पे आया. हाँ, basically this is yes. So if you want to treat it as addition, then it is the vector Ri plus D is equal to Rf. If you want to treat it as addition, then vector Ri plus vector D is equal to vector Rf. Or I always find it easier to treat it as subtraction. Why? Because the green arrow and the blue arrow have been drawn from the same point. Right? Remember that all of our vector operations, they start when two vectors are drawn from the same point. So if Ri and Rf are drawn from the same point and then I draw a vector from the head of Ri to the head of Rf, that is vector subtraction. It is the diagonal of a parallelogram. Right? It is the diagonal of a parallelogram formed by Ri and Rf. But it is not the sum wala diagonal, it is the difference wala diagonal. And remember, if you go back through your notes, then you will find that to subtract two vectors, you draw the two vectors together and then you draw a vector from the head of the negative vector to the head of the positive vector. Therefore, I can also express this as D is equal to Rf minus Ri. Okay, D is equal to Rf minus Ri. Now I'm going to change the slide. Okay, so the displacement vector D is final position vector minus initial position vector, right? And we can define now something which you have already seen before in class 9th and 10th. Not like this, of course, but you have seen this. Velocity vector is the displacement vector divided by time, right? Okay, so this means that the velocity vector is equal to the displacement vector divided by time. This I can write as Rf minus Ri is equal to velocity vector into delta t, or I can write this as Rf is equal to Ri plus velocity vector into delta t. So this expression is basically a vector equivalent, okay, or you can take any of these expressions as the vector equivalent of speed is equal to distance upon time. Okay, speed is equal to distance upon time in vectors translates to velocity is equal to displacement upon time. So the velocity vector is equal to the displacement vector upon time, and the displacement vector happens to be the difference of two position vectors. Therefore, the final position vector of any particle is the vector sum of the initial position vector of the particle plus the velocity vector of the particle multiplied by time. Yeah, समझ में सबको? I mean, I'm not doing anything. I'm not doing anything very complicated or very weird. All I've done is I have defined the position vector, and then I have defined the displacement vector in terms of these position vectors, and then I have defined the velocity vector as displacement vector divided by time, right? Okay, now let's see if you can apply this. So I'm going to write down a question. The question involves only one formula. Speed is equal to distance upon time. So the question is something like this. But this question must be done now using the techniques of vectors. So a particle located at uh, 2, 1, 2 meters moves towards the point 4, 3, 1 meters with speed of 2 meters per second. Find the coordinates. नहीं, velocity vector or relative velocity अलग. Find the coordinates of the particle after 10 seconds. I'll give you 5 minutes to solve this question. Don't worry if you can't solve it. I will, of course, solve it. But can you use the knowledge of vectors that can you use the knowledge of vectors that you have acquired for the past 6-7 lectures and the knowledge that has been given today, especially this page. सबने क्वेश्चन लिख लिया है या मैं क्या करूं, क्वेश्चन पे जाऊं या ये पेज रखूं? क्वेश्चन लिख लिया सबने? Please take a snapshot. Please take a snapshot of this. Please take a snapshot. क्वेश्चन पे ही हूं मैं आयुष, देखो. Take a snapshot. लिया snapshot सबने? Take a snapshot of this page, please. Lilia snapshot. Okay, now I'm going to go to this page. Why do I want to be on this page? Because this is the formula that is going to be used. Chalo, I'll give you 5 minutes once more. Good. So some of you have attempted, tried. Let me show you. Okay, so the question is telling us that although the question is in 3 dimensions, I'm going to draw it in 2 dimensions. Question is telling us that we have a particle which is located at a certain coordinate, and after some time the coordinates of the particle changes to something else. Sorry, गलत बोल दिया मैंने. The particle starts to move towards another point in space, and we have to find the coordinates of the particle at a particular moment in time. So according to the question, the particle is located at 2, 1, 2. Particle is located at 2, 1, 2, and it starts to move towards the point 4, 3, 1. ठीक है, मेरा डायग्राम 2D में है, कोई फर्क नहीं पड़ता है उससे. It is just a diagrammatical representation of what is going on. So the particle basically moves along the red line. Okay. The particle basically moves along the red line like so. So let's break up the question bit by bit, try to understand what is happening. A particle located at this coordinate moves towards this point with a speed of 2 meters per second. We have to find the coordinates of the particle after 10 seconds. So the position vector of the particle is a vector drawn from the origin to the location of the particle. So at time t is equal to 0, the position vector of the particle, which we will call the initial position vector of the particle, will be equal to 2i cap plus j cap plus 2k cap meters. How did I arrive at this? Well, this is using the concept that we learned, I think 2 days or 3 days, 3 lectures back, that a vector drawn from the origin to the point having coordinates x, y, z is simply given by xi cap plus yj cap plus zk cap. So a vector drawn from the origin to the point having coordinates 2, 1, 2 must be equal to 2i cap plus j cap plus 2k cap, right? That is what I have written. The difference between what we were doing then and what we are doing now is simply the fact that we are dealing with vectors having units now. I have to write units. The position vector must have the units of length. In this case, we have chosen meters. Now, what is the final position vector of the particle? Well, the final position vector of the particle is tricky because the final position vector of the particle means the position vector of the particle at a certain time. And position vector is a vector drawn from the origin to the point where the particle is located. And since the particle is moving along the red line, this means that as time goes on, the final position vector of the particle is changing with time. Right? So at some point of time, this is the position vector of the particle. At some point of time, this is the position vector of the particle. At some point of time, the position vector of the particle coincides with the green vector. Right? And just after that, this is the position vector of the particle after that, this is the position vector of the particle. So the final position vector of the particle keeps on changing with time. At a certain moment, it is going to be 4i cap plus 3j cap plus k cap, because the particle is moving along, is moving towards the point 4, 3, 1, right? It does not mean that it stops at 4, 3, 1. ना आप यहाँ से दिल्ली की तरफ जा रहे हो, राइट? इसका मतलब ये नहीं है कि आप दिल्ली पहुंच के रुक जाओगे. You are free to go ahead. You are free to go beyond. So to find the final position vector, which is being asked, by the way, in the question, all I have to do is I have to write down the formula, which is Ri plus velocity vector into delta t. So the initial position vector of the particle is given to me, right? This is the initial position vector of the particle. This delta t is also given to me as 10 seconds. Therefore, all I have to do is now put in the value of v, and that's it. Khatam ho gaya kaam. But there is a problem. The problem is that the velocity vector is not given to me, but the magnitude of velocity vector is given to me as 2 meters per second. Right? So now what we are going to do is we are going to use the concept of unit vectors. Okay? Remember, the concept of unit vectors is that the direction of the velocity vector is equal to the velocity vector upon the magnitude of the velocity vector. This means that to find the velocity vector, I simply have to multiply the direction of the velocity vector with the magnitude of the velocity vector. Magnitude of the velocity vector is already given. It is equal to 2. So the velocity vector must be 2 times the direction of the velocity vector. Now, there is a serious problem. What is the direction of the velocity vector? Well, it's not that big a problem, because I know that the direction of the velocity vector must be the same as the direction of this black vector, right? Let me call this vector A. So the direction of this vector A is the direction of the velocity vector, right? I'm going to change the slide. So vector, please notice that I'm not calling this the displacement vector, because this is the displacement vector only at a particular moment in time. Okay? अगर particle यहाँ पे है तो ये होएगा displacement vector. अगर particle यहाँ पे है तो ये होएगा displacement vector, right? अभी particle हमारा कहाँ है ये हमें नहीं मालूम. तो ये A जो है, it is a vector which is drawn between the points 2, 1, 2 and 4, 3, 1. Okay, so I write in the next slide, I write the direction of vector A is the same as the direction of the velocity vector. So this is a very unique feature of vector mathematics, that you are actually equating the direction of 2 different objects. The A vector that I have drawn will have a units of meters, and the V vector is having a unit of meter per second. Therefore, you can never ever equate them. But if you remember, if you go back, I told you that the unit vector is a vector which is unitless, dimensionless. So the direction of A does not have any units, although A has a units of meters. The direction of v does not have any units, although the velocity vector v does have units of meters per second. Now the direction of vector A is simply vector A upon magnitude of vector A. This should be equal to the direction of velocity. Now what is vector A? अब अगर मैं वापस से डायग्राम में जाऊंगा तो मेरे को तो साफ दिखाई दे रहा है वेक्टर ए क्या है. अगर ये वेक्टर ए का टेल ब्लू वेक्टर पे है और उसका हेड ग्रीन वेक्टर के हेड पे है, तो वेक्टर ए मस्ट बी द सबट्रैक्शन ऑफ ग्रीन वेक्टर एंड ब्लू वेक्टर. So vector A must be the green vector minus the blue vector, right? And therefore I can write the vector A as 4i cap plus 3j cap plus k cap minus 2i cap minus j cap minus 2k cap divided by the magnitude of whatever I am getting upar. So let me just rewrite this. Vector A upon mod of vector A is equal to the direction of velocity vector is equal to, ऊपर क्या आ रहा है देखो, 4 minus 2, that is 2i cap, 3 minus 1, that is 2i cap, plus k minus 2k, that is minus k cap, upon the magnitude of this 2i cap plus 2j cap minus k cap, right? यहाँ पे j cap आएगा, ये क्या हो जाएगा, magnitude is 3, so this is 2i cap plus 2j cap minus k cap upon 3, right? Magnitude क्या होता है, root of x square plus y square plus z square. इस केस में हो जाएगा root of 2 square plus 2 square plus 1 square, which is root of 9, which is equal to 3. So now I have, remember what was missing from this? वेलोसिटी वेक्टर मुझे निकालना था, लेकिन वेलोसिटी वेक्टर का मैग्नीट्यूड दिया था और डायरेक्शन मुझे नहीं मालूम था, लेकिन अब मुझे डायरेक्शन पता चल गया है. सो नाउ आई कैन राइट द वेलोसिटी वेक्टर ऑफ द पार्टिकल, एंड द वेलोसिटी वेक्टर ऑफ द पार्टिकल विल बी 2 into the unit vector, it will be 2 by 3 into 2i cap plus 2j cap minus k cap meters per second. और अब मैं फाइनल पोजीशन वेक्टर निकाल देता हूं. फाइनल पोजीशन वेक्टर इज इनिशियल पोजीशन वेक्टर प्लस वेलोसिटी वेक्टर इनटू टाइम. इनिशियल पोजीशन वेक्टर ये रहा, so this should be equal to initial position vector plus velocity vector into time, which is equal to 2i cap plus j cap plus 2k cap plus velocity vector into time, which is 2 by 3 into 2i cap plus 2j cap minus k cap into 10. अब आई कैप वाले टर्म्स अलग कर लेते हैं, जे कैप वाले अलग कर लेते हैं, के कैप वाले अलग कर देते हैं. तो इसमें आएगा 2 plus 20 by 3, sorry 2 plus 40 by 3. What is 2 plus 40 by 3? 46 by 3 आई कैप. फिर आएगा 1 plus 40 by 3. 1 plus 40 by 3 is 43 by 3 j cap. और फिर आएगा 2 minus 20 by 3, right? 2 minus 20 by 3, which will be equal to minus 14 by 3 j cap. Right, so this is the final position vector of the part. ठीक है, magnitude of 2 I cap plus 2 j cap minus k cap should be 7. कैसे आएगा 7 भाई? 7 कैसे आएगा? लास्ट में k cap. हाँ भाई 7 कैसे आएगा? Magnitude of 2 I cap plus 2 j cap minus k cap. 7 कैसे आया? ये मुझे एक्सप्लेन करना पड़ेगा. तरुण, हाँ तरुण, 7 9 आ गया, मतलब क्या चेंज हो रहा है क्या? आया ना समझ में? अंडर रूट एक्स स्क्वायर प्लस अंडर रूट नहीं ले रहा था ना, इज इक्वल टू अंडर रूट ऑफ 4 plus 4 plus 1. Right, so this, yeah, this completes vectors. तो अब आपको